hope you all are well. In today's video, we will study about the design guidelines for in designing for the thick film hybrid circuits. So before moving forward, I request you all to please subscribe the channel and press the bell icon to get the notification in the future. So without wasting time, let's move on today's topic. Now let's discuss the major steps in the designing for the thick film hybrid circuit. So the first step is that we should make a list of all the components of the given circuit. Why we are doing this? So that we can determine the substrate size, which will help in the determining for the package size. What kind of package in which we will pack this uh, thick film circuits. Second is we should determine the power dissipation of each component. Why? Because this will help to determine the ability of package, that in how much this package will dissipate the total power. And lastly, the layout the circuit so that it can be fabricated. This will help. This means that drawing a layout scale, drawing the layout to the scale at least 10 times the final size, so that it can be used in the preparation for the Ruby length network. Now, what this Ruby network is? It is used in many areas for the graphic designing, in preparing for the mask, for the printing techniques. So this was the major steps for designing of thick film hybrid circuits. Now let us move forward and talk about the designing for the resistors. So now let's discuss about the designing of the resistor. So for designing of the resistor, first let's talk about the sheet resistivity. Now sheet resistivity, suppose we have a block who have a uniform thickness of T, width W and length L. So the bulk resistivity, or you can say resistivity per unit volume of the thick film paste is rho ohm centimeter. So to determine to measure the resistivity, we know that the R equal to rho L by A. Now L here is the length and A is the area of the block. So how to find out what is the area of the block? So what I do here is I kept this block in the vertical position. So rho L by W into T, widthness into T, it will become W into T. So I can say that R equal to rho L by WT. So rho by T is equal to the rho S, or equal to sheet resistivity, and L by W is equal to the aspect ratio. So I can say that R equal to rho S into aspect ratio. So this is how I can measure the resistance of this block. And also the sheet resistivity is the most basic design parameter for the monolithic IC circuits, and most resistive paste is between 0.8 mils to 1 mils of thickness. So this was the sheet resistivity of the design in the designing of the resistors. Now let's move forward. Now for designing of the resistor, we should know that the aspect ratio should not be greater than 25:1, or it should not be less than 1:3. Why? Because we have to change the sheet resistivity, and we have to start all over again. Because it is important to select the sheet resistivity to minimize the number of screening required, and hence reducing the cost. Now the other factors like power dissipation, temperature tracking, voltage stress, and laser trim are also important in choosing the various resistor geometries. Now we have three types of resistor geometries which are on your screen right now. So the next step in the designing of resistors is the trimming of resistors. After filing in the manufacturing of resistors, we trim the resistors to attain the desired value. Owing to the variance in materials, screen thickness, screen geometry, and filing parameters, the typical thick film resistors have tolerance of plus minus 20%. However, tighter tolerance resistors are designed at a lower value at the layout, and then after trimming, they attain the required value. So the various trim cuts and geometries are on your screen right now. So we have different types of trimming. First one is abrasive and second one is laser. So now we will discuss about these two one by one. Now let's talk about the one of the types of trimming, that is abrasive trimming. It was the first method developed for the trimming of resistors because it does not involve heat. Because heat is not involved, it produces more stable resistors with no stress or micro cracks in the materials. So how this abrasive trimming was done? Fine grained sand is forced through a small nozzle under high pressure, and also there was a main drawback which because of which this method was not used now. It was because of these materials, is the debris, which was a highly contaminated materials. So because of this drawback, laser trimming was invented. So now let's talk about the laser trimming. So now let's talk about the second type of trimming method is the laser trimming. Because it involves a laser, it is used to adjust the operating parameters of the resistors. One of the common application uses a laser to burn away the small portion of the resistors, hence raising its value. Also, a lateral cut in the resistor material narrows or lengthens the current flow and increases the resistance value. Also, the SMD resistors are also fabricated or also trimmed using this method, and with this we can also raise its required value. So this was the second trimming method of in designing of the resistors. I hope you understood our today's video. See you in the next video. Till then, thank you very much.